Hello, welcome guys. Here's another question. A body of mass 5 kilogram initially at rest, underline the word at rest, is acted upon by two mutually perpendicular forces. Underline that please. 12 Newton and 5 Newton are shown below. If the particle moves in the direction OA, that is from the diagram, calculate the magnitude of the acceleration. Triune components, we have the mass, the force, and acceleration. Okay, so let's depict the diagram. Okay, a vertical axis, which is one of the forces, then the horizontal axis, which is the second force, mutually perpendicular to each other. Then, of course, we must find our resultant vector, which is force, OA, okay? Then for x-axis, 5 Newton, y-axis, 12 Newton. Is that clear? So we're going to solve for OA. Then we can now solve for acceleration later. I hope you are following. So the resultant force, solution. The resultant force acting along OA. Observe OA. Let's use dotted lines. You can see it OA, which becomes hypotenuse. Okay? Now, let's redraw this diagram. So, vertical force, horizontal force. Then we'll complete this using dotted lines so that it will give us the shape of what? A rectangle. And of course, you know the vertical axes are equal. The horizontal axes are also equal. So the resultant, OA, is what we are looking for. Is that clear? So 12 Newton is equal to 12 Newton, 5 Newton is equal to 5 Newton. Then our resultant vector is unknown. I hope you are following this. Please join us when we shall be treating vectors and their calculations. So using Pythagoras theorem, we know that hypotenuse squared is equal to opposite squared plus adjacent squared. Resultant vector squared, which is resultant force squared, is equal to vector 12 squared plus vector 5 squared. Okay, but recall they are both forces. Hence, r squared is equal to 12 squared plus 5 squared. So that your r squared is equal to 144 plus 25. So that r squared is equal to 144 plus 25 is 169. Okay? Then we are going to take the square root of both sides so that r squared is equal to 169. So take the square root of both sides so that square root will cancel out squared. Then we are left with what? R is equal to square root of 169. So vector R is equal to 13 Newton. So that's our resultant force. Recall that the equation is asking us for acceleration and we are given mass to be what? Mass is equal to 5 kilogram. Can you see it? 5 kilogram. Then we are asked to calculate for acceleration, which is A. Are you here? Then we're able to calculate for our resultant vector, which is F, which is force. Let's get to it quickly. Our M is equal to 5 kilogram. Our R resultant vector is equal to 13 Newton, which is our resultant force. Our A is equal to unknown. I hope you are following. Now, if you recall from our linear momentum, F is equal to MA, right? So using F is equal to MA, then we can say that our resultant vector or force is equal to MA. Now, let's substitute into this so that 13 is equal to 5 multiplied by A. So that 13 is equal to 5A. What next? We divide through by 5. Divide both sides by 5. 5, we cancel out 5. Hence, A is equal to 13 divided by 5 will give us 2.6 meters per second squared. This becomes our final answer. Connect to our social media handles at PhysicsBible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.